Yeah. So how does your stuff relate to that? Is
It's
it
a
like
lot,
I think
more
it is a lot more
breakdown.
complete.
it's not like it's like more it's like can it come as a follow up to like just this presenting the first list or
Yeah, I mean, I'm trying to. Okay, so I'll bounce this one down first so that you can have it up there because it's a replacement. I'm just doing it right now.
yeah.
I'll be like 2 minutes.
So but can this serve as an introduction to your
Yeah.
to your more breakdown
Yeah, I think
presentation
yeah.
or is it
Yeah.
like is it not?
It's a direct replacement, really. So perhaps there's not much point in. I mean, I'll be like 2 minutes. I'll just email in a second. I'm literally doing it right now.
I don't think you need the whole block.
Yeah, well, yeah,
It's not yet.
It's not really
yeah, I hope, yeah, you can hear me. Yeah, we are starting. Okay.
I noticed.
Okay, yeah, well, we are here to try to converge in some ideas and further work on over-the-air updates. Officially, in Riot, there were some pull requests. They were quite big, and none of them made it into master. So we decided to more or less divide the work and separate the work more into several aspects. On one side, we have the aspect of the need of a linker and, well, the linking images for updates and a bootloader to boot them. And on the other side, the actual transport method for these updates. So there were some pull requests already open. It's not completely updated, but mostly it's about generate images that can be updated and generate the actual updates which are linked in a different place. And some ongoing pull requests for the over-the-air issue. So I think Dan?
Yeah. I've just emailed you it.
Okay. I think that will send some more detailed composition of the left part, is it?
It's the whole thing. Just
Okay,
a
the
lot
whole
more detail,
thing.
basically. All components, and I've also extended it to support for all different boards. Although it's like a lot less granularity.
So while you set this up, maybe there are a lot of people here who maybe have no idea like what we're doing. So this is like already like way into the details. So just to give the context, like we're trying to develop a prototype that's going to be doing OTA firmware updates. Okay, and we just for a very short overview of the approach we take, which is very basic. We have a small bootloader, which is a small, very minimized version of Riot, and two firmware slots that then alternate between one and another. So one running, and we have developed a small firmware update module inside each image that is able to actually fetch the image, flash it to the currently unused slot, and then boot it through the bootloader. Okay, so it's the most basic, let's say, approach that you can think of, and this is the framework in which we're working and the prototype that we're trying to get to. Okay, and then there are various aspects of like that, and this is like those different steps that we're discussing now. So just as you, just as a framework that you understand what's going on. Do people have questions at this point, or comments, or is it clear, like a little bit, like what we're trying to do? Yes? No? Yeah.
Maybe one question. This is not a memory management unit device. If you link an application, it's with absolute addresses. So how can you run from two different slots?
So maybe
he's going to
answer.
Yeah, actually, we reserved the first. I mean, we were partitioning the ROM, the flash memory, The first partition is the bootloader, which will always run at reset. And the bootloader will look for images which are stored in a fixed linked position. So this is happening at build time. At build time, we decide which address is the starting address of each image, and the bootloader will look at some metadata which is added to each firmware when it's generated. So this metadata has information about version, about where it's stored, and where you need to actually run the application, because this metadata is taking some offset in the beginning. So we basically tell to the bootloader, jump to this specific address, and you will find the application. So this generates only one problem, on which if we lose track of which slot is running, we need always to send the two images. I mean, the same application compiled for the two slots, and then the application knows on which slot it needs to flash the update. We will fetch the correct one. So we don't need to really care too much about, as long as we compile both linked images, we are safe.
You need to build it twice,
No, just link it twice.
link it twice.
Yeah,
Okay.
which is quite fast. We compile once, we link twice.
Yes, and you have to set the right image, to
Yeah, yeah. I mean, the management of how you fetch or how you, that's independent. We are just providing the generic tooling and generic approach to generate images that are linked in a specific place, and as long as you flash it somehow. Huh?
Suppose you have 3 slots.
This,
Then
I
you
mean,
build
it's always possible, but the thing is that we find it not super useful.
No.
Because as long as you have only the space necessary to store the next, that's enough.
Probably possible to extend it to 3 slots, but
Actually, the original idea was to store them outside the flash, but then it's not you cannot ensure that on Riot that all the boards we support have external flash. With external flash, you can store as much slots as you want, but the basic approach is to ensure that every board that we have is able to do an OTA update.
Basically, get for something like simple prototype, and it's as simple as possible. You could then be, extended and modified. You need a third maybe for a factory reset or whatever, and whatever. Using the elements, this building blocks that we're trying to factor out, it should be easy to little work to get to the point.
Okay.
So that's the goal we're trying to aim for. Something basic that can then be customized and improved.
So maybe someone has.
Have you considered MCU?
Yes, actually we worked with them a bit. We have a working prototype with them. The problem is that right now we don't compile MCU boot with Riot. We are able to. Yeah, we are able to boot Riot images with any MCU boot compiled bootloader, which can be Zephyr or Manit, and we generate Riot images with correct headers and signatures and things that we are compatible with them. Yeah. Now the problem is that we have right now is that we don't support the same boards as they support. So not all the boards that they have a bootloader for, we have them too. So for now we are only compatible with one board, as far as I remember, the NRF52 DK, I think. And but yeah, the aim is to maybe have compatibility for on the boards and even compile MCU with Riot, which will enable that any support any board supported by Riot would run MC-Boot. But it's quite challenging.
I'm asking because on the MC boot, it is bootloader that is doing the swapping of the
Yes.
1 and 0, so you don't need this linker magic, different base
Yeah.
images.
Yeah.
I saw this kind of solutions in vendors that are doing that, and the problem is that you need to know which slot is being actively used before you can do OTA. So you need a mechanism, for example, on the mobile app that will be doing the OTA or whatever will be the gate OTA, which image to upload.
Yeah, I think this problem you have it when you're doing push updates, but we also want to provide a pull update mechanism. On the pull update mechanism, the application of course knows where it's running, so it will fetch let's say make a HTTP request or a QAP request or whatever to a server saying I want to know if there is an update for this application and for this slot. So then the server can actually send the right image because we are anyways linking twice. I mean, we link for the both. They're available always, both, and then the application decides which one is the actual update. So we solve the problem this way. I agree that the swapping technique is quite nice, let's say, because then you don't need to worry about anything. You just provide always the image linked for the first slot. And ensuring you that you have enough space for the storage and for the swapping. Also we aim for the most easy and straightforward mechanism of bootloader. So if we add a lot of complexity to bootloader to do swapping and even signature verification and everything, we lose in booting time and we add new problems.
Yes, that's why I'm asking why not just use MC boot.
Yeah, sure, but it's
at least this is the Zephyr way at least they adopted it as basically like option. I'm using MC boot and that's it.
We might support it, but one thing is that MC boot is too fast for some of our target boards.
Too fast means
Too much.
it's very big.
What is the expected size of the boot?
We have a bootloader of 3K.
How many?
Less than 1 page.
Less than 1.
As small as possible. Right now, the bootloader is like 20, 30 lines.
Yeah, actually, we managed to get down with like 14 kilobytes with a signature of the key. So I'm not sure how you like to verify the.
We're doing it like
It's only the application
It's in
level.
the application.
Yeah,
How do you
because
manage?
anyway you need to fetch it.
Yes, so you are targeting a bootloader of 3K, but if you put a lot of features in your bootloader, I mean maybe an USB stack because you want to upload through USB, you won't fit the 3K.
But I think that's another application level.
Yeah, no, but,
It's very well possible, but that's not yet what we're aiming here for.
yeah, but I think you have to think of it.
Anyways, all of these sizes are flexible. I mean, it's configurable. You choose at your when you're building the application. I mean, your update. How long, how big is the partition for the bootloader? So if ever you want to implement your own bootloader, the mechanism is there. So you just say, I need a space of, I don't know, 32K for my bootloader and the next for slots. Then the build system will interpret that and then will flash whatever bootloader you want with the features you want. But the aim right now is just to provide the mechanism and to make it as slim as possible.
So one more question: if you are not going to verify the signature of the bootloader, how do you want to have a secure boot? I mean, how do you know the application that you are starting is not modified because of I don't know, it was tempered by buffer overflow attack?
The idea there is that if the running application is able to flash, it can always flash the bootloader. So
you could have a bootloader possibly turn into read-only mode on those pages.
yeah.
At least that's the architecture that is supported by MC Boot. They say that you should do it.
And in that case, from my perspective, I think that you shouldn't like run the device that much. But if you interesting flexibility. It is possible with this kind of bootloader because the bootloader is basically just a small write. The all-in-one is the same. So if you want to on the crypto in the bootloader, you just use module 8, then it's going to just make the bootloader larger, but you have to.
But if you can read only logbook pages, there's not much point of checking the crypto in the bootloader. Why? Because the application could have overwritten.
No, I mean that if, at least currently MCU boot is done in a way that you have a hard-coded public key there that's used to verify. So if the flash is read-only, you cannot modify it.
But which chips do actually have that capability?
I'm not sure. I think it's Nordic chips probably has the fuse chip or whatever.
Yeah, I think there is this ARM choose code zone or
I'm just
something.
asking because it seems to me that you will be reinventing MCU boot eventually.
No. I mean, I was working with them and I studied how actually it works, and we decided to decouple this part of the bootloader specifically for the aim of having a slim bootloader and a fast boot, and all the parts of verification of signatures, hashes, integrity, etc. are done at the application level.
Okay.
So actually, that also makes you kind of flexible on the way that. I mean, the bootloader still don't take place, so you can use more or less place for your application, and the bootloader stays the same.
Can I ask something about MCU boot? It's because from the user perspective, it's still not clear to me how to actually compile it.
And, yeah, well, MCU would need to be compiled using either Zephyr or Minute.
So I need to
It doesn't.
install
It's not
another
the
operating system in order for it to
Exactly.
be able to compile it.
Yeah, you cannot compile it standalone. It's not bare metal coded.
I think this is a big limitation of this bootloader because it's completely useless unless you get into the minute.
Yeah, the problem with
behind this is that your bootloader supports the same board you operate with, right? So you don't have to have a per device the specific bootloader.
No. I mean, what is the build process to build MCU boot for Riot?
No, MCU boot is not built for Riot. We have a built, a pre-built binary which is flashed at the beginning of the flash, and then we can flash Riot at a specific address which MCU boot is already expecting, and MCU boot does all the verification mechanism of signatures and everything that needs to be verified, and then boots something. Actually, MCU boot is agnostic of what is booting. We just read the metadata that is contained in the image. It can be Zephyr, it can be Minute, it can be Riot.
But this is the actual way it works. But the compile.
Yeah, currently compiling MCU boot with Riot is not possible because we didn't have. I didn't have make a package, for instance. That would be the way to go. Like we make a package of MCU boot in Riot, but it needs a lot of wrappers to meet the API of MCU boot, which is for now not super straightforward, but it's not also impossible. I mean, it should happen sometime.
So is there some way that the MCU boot people could help out here and help with the effort that's needed to actually create MCU boot as a Riot package?
I think
That's a showstopper for us to actually even consider.
That's
So,
what was done for Zephyr, right?
Yeah.
You basically have a Zephyr application inside MCU bootloader source code that you basically build from your Zephyr installation. And
so that's exactly what we need.
Why it should be done
Right now, like nobody's doing it, and so in the community here, and so it would be great if like the MCU people would help out here, and so I know that you're only indirectly related with MCU people, but like if you can convey this message back to this community,
Yeah,
that
I guess the
would
easiest
be
way
great.
would be to create a GitHub issue.
Yeah.
Maybe there is, I'm not sure.
Yeah.
But
So,
I can ask them.
so please take this in your hand. And the second thing that also like kind of steered us away from MCU boot was that the metadata that they're using so far is like non-standard. There's no, they do their own things. Whereas like we wanted to make sure we are able to use specs that are currently upcoming in the IETF like suit, right? So there was like a couple of things that made us like, okay, you know, we're gonna go for something simple, you know, that's not going to use MCU boot, and then, but you know, in the future, you know, everything's possible. We just want to have something now, and this flexibility of being able to adapt to the suit specs and whatever. That's what drove us to where we are now. So yeah, please convey this message back to the MCU boot community, right?
Yeah. Don't know if there are more questions. No, don't think so. So
Yeah,
it's got to sleep. Okay. So yeah, what we need to know also is that we have prototypes at work. I mean, there is already done by Kuhn and by some. Huh?
I'm sorry, I'm a bit lost. So I just happen to know that there is another MCU boot community, and then we find that MCU boot here in the GitHub is supposed to run.
Yeah.
And then why you? Because you want to do something else, but to replace something, and then the reason is why.
Yeah, actually, what we were explaining is that MCU boot does the thing in a way with their own formats, with their own, let's say, homemade methods, and we aim to actually support standards. And for instance, there is one a standard called, well, a working group in the IETF called SUT, and there, well, we work all together to try to converge into a format on how the update should look like, especially in the security part. The problem with the main issue with OTAs with OTA that we want to solve is the security issue. I mean, if there are bugs in your application, you need to be able to update it to avoid these security threats. And the problem is that also sending updates or receiving updates it can be dangerous, because if your image is taken by someone in the middle and changes the image, then you are insecure anyways. So the goal is to provide a secure method to be completely sure that the image you are fetching and you're flashing in your device comes from the person who you are expecting. And this is currently done using cryptography, mostly asymmetric. And maybe Kuhn can explain more this part. Yeah.
And then the MCU boot loaded there, it says also it's a secure boot, but what is secure mechanism there, and how you improved?
Yeah, they took into consideration several things, and they're signing their images with a key, a cryptographic key. Yeah. So that's the method, that is the preferred method. But the thing is that if you want to update using MCU boot, you need to stick to their own standard, which they develop by themselves. So what we are trying to do is to meet some more IETF standard, which is made by a lot of people, and we converge into something. I mean, it's very community driven. So it's not decided by one person, but by a community.
Just to answer, maybe Kuhn can answer better. Yeah. But the support that MCU is claiming for, right, is like reverse. Like you can from the bootloader like put some riot images, but we're talking here about the bootloader itself, and then there like it's sensitive. And second, the metadata that they use is non-standard, whereas like we're trying to use something that's going to be standardized by the IETF. So the metadata. Okay, so this is the difference.
What's the name of that standard?
SUIT. S-U-I-T. So maybe Kuhn can take over a bit.
If there's more interest, if there's interest in how SUIT works, what we're aiming for is compliance with their manifest format, and that's also one of the things they explicitly do is only define the format of the manifest. So what we have here is we're trying to get this working over CoAP as preferred transport method. if you like, you can probably plug in any transport at some point you want via some module. But at the moment, we want to get block 2 support in to transport the image to the node, and we need a suit parser. Now, this suit manifest contains all the information you need to securely get this image over to your node. The manifest itself is cryptographically signed. On the node itself, it's verified with an, at the moment, hard-coded key. There's an hash inside the manifest to verify the image itself. There's some additional metadata such as an incremental number. I'm not allowed to call it a timestamp anymore. To be able to verify that the update is an actual update and not a downgrade. There's a URL where to fetch the image from. And this component that still needs to be PR'd and merged should be able to fetch the update image, pull it in, verify it, and at the same time flash it. And when the image is validated, the metadata in front of it gets written, and the bootloader should be able to find it and boot it. Any questions, comments so far? Yes?
You just mentioned a hard-coded key. Where is that and what is that?
At the moment, the idea is to have a simple hard-coded key in the firmware of the device itself to validate the image. And we're just using simple asymmetric cryptography, ED25519 based things.
Once this key is get by some, for example, bad
Then the
updates, then they can steal like
No, we're saving the public key of the...
Yeah, it's only the public key, so your attacker can then validate that your update is valid. I don't think that's much of a problem.
Okay. So that is like in the firmware itself is the private key, and then
No, it's only the public key.
Private key.
Yeah. Only the public key.
And then in the for the server they provide the private key, and then you can verify to use your hard-coded public key. This is symmetric keys.
During the build process.
During the build process, you embed the key on the firmware.
Yeah.
And if ever the server gets compromised, even Suit provides mechanism to actually revoke the key and then provide a new in a subsequent date.
How does the key revocation work? Is it by date? Because many devices don't have an actual timestamp.
I'm not clear anymore on the details of this.
Right.
So if you...
Well, we can answer like with how we plan to do it with this initial prototype. The initial prototype is not time-based. It's like since like the public key is baked in the firmware update, then you just need to change the public key in the firmware update for the next update, and then you automatically revoke and then relinquish to this new.
Sure, that's not in the book for the.
Yeah, no, the bootloader does not.
Yeah, and that's it. Like you know, you could use the same standard, metadata standard, to do something else, right? And to use some timing-based, like we want to use the standard in the most simple.
No, but it's simple enough. If you can replace the key because it's part of the image.
So in this prototype, we're so it's possible to transfer your authority, the authority of maintainer to another maintainer.
More questions so far, comments?
Yeah, so maybe we can pass to the diagram.
Yeah, I emailed you.
That it's going to be
Lots to digest. But we'll see. It gives an overview of the implementation that's in the Suit Hackathon branch, which is like our working branch at the moment. So we've got a branch on Paco's repo that we're working from, and at the moment it's being rebased on master, and we're going to create a PR basically, keep that open and take bits from it in smaller PRs. That's the plan.
Okay, I have several, but I will open the free one.
You put quite some work in this, right? You put quite some work in it.
Yeah.
Nice.
Yeah.
It's probably 5 minutes of work or something.
Yeah, right. I think, yeah.
Okay, well, the nice thing is that it has the numbers of the PRs that were already open, and but I don't know, maybe you want to explain it better?
Yeah, sure. So yeah, it's there's some changes from the original work breakdown, and basically you can see that the kind of bottleneck in the process is getting a bootloaded firmware build, which is right in the middle, and there's some prerequisites to this. For example, being able to make a CPU init function that can be called twice is something that we're working on at the moment. Because it's going to be called in the bootloader and the main firmware. And there's also some metadata handling stuff in there. So then if we go further down, we start to implement the suit metadata. And this stuff up here is basically firstly non-suit metadata, and then further down implementing suit metadata. But basically, the logic goes that firstly we get some tooling in place that can handle like partial ROM flashing, for example, which is mostly done, and then we can flash a firmware and bootloader into the same ROM. We can also handle metadata in terms of the tooling, and we can have an initialization function that works in the bootloader and the firmware. So then after this we go to 2 firmware slots, still no update, and then we go to being able to do an update with, over CoAP, and as I say, go down to like handling more secure suit metadata and then eventually porting to other boards. So that's like the general workflow that I think would be most sensible in terms of breaking down the current implementation in terms of like how do we get it merged in the right processes. And this is a system breakdown. You can't really see the font very well.
Where you can see the fingers.
Well, I can describe the blocks, and then I'll zoom in. So basically, on the left there is the bootloader. As you can see, there's a circular dependency somehow. I don't know if that's okay or not. And then on the left here is like some kind of like firmware handling stuff. So this is the stuff that writes to the flash and handles slot switching and handles slot writing. So this is all application code. So we're writing this stuff into the actual application, not the bootloader. And then if you go across to the right, there's kind of the low-level stuff, like the CPU code, which like linker scripts and image jump functionality. And then going across to the right a little bit is the suit manifest deserialization. which is a dependency of the manifest handler, and being able to jump to different, to be able to download the metadata, and so it gets the manifest first, and there's a pointer in the manifest to the location of the main firmware, which it then gets from another server potentially, and then across to the right is the so this is all the application layer stuff in SysNet. And so, as you can see, NanoCoAP Block 2 support is a dependency of the eventual implementation. Now, at the moment in our repo, we've basically got two implementations side by side. We've got the suit-based stuff, and we've got just a simple metadata. So suit is metadata for a firmware image. And so at the moment it's push-based, so we've got a CoAP server running on the device, and so eventually we want to make it pull-based because we don't want to keep an endpoint open on the device, because you can get like attacks that will drain the battery of the device by doing crypto stuff. So by making it pull-based, we avoid that. So once we have Block 2 support, we can do that. And then if we go up a little bit, we can see that there are some example applications, and at the moment there is there's a metadata one and there's a suit one. So yeah, so that's like all the stuff that's kind of dependent on each other. Then we've got some stuff down at the bottom here, which is like tools to help and makefile stuff. So for example, edvg.inc.make will allow you to flash part of the ROM without erasing the whole thing. And then, yeah, and similar for OpenOCD. So that's obviously EDVG stuff at the top. And then in terms of the build system, we need to be able to build separate targets in partial areas of the ROM, as well as flashing them, and defining that in the makefile for CPU Cortex-M common, in the case of Cortex-M type CPUs. And then there's also a program that we've got to generate the key pair, which at the moment is ED25519. So there's some conversation around how we do that eventually, whether we would use our own program, or whether we'd use like a third party. So that's basically it.
There is no such discussion. I mean, you're definitely going to use some third party.
Right. Okay. Fine. Okay.
There's
no discussion.
We're not, cryptographers here, so
yeah.
For sure we're going to use something that's
Okay. Cool. So that's basically it. Awesome. I'll hand back to you.
Thank you. Can we switch back to the current? Now the first flow chart, I think. Yes, this one. So as then told, we have this. Yeah, slightly up. No, yeah. Okay. Thank you. This is where we are at the moment. And as then told, there's this bottleneck here for our prototype. And one of the issues is that some of these PRs that we have to implement, merge, are quite generic, like the Cortex things we can just, in one swap have support for like one architecture. Other parts like the CPU in it, if I'm correct, that one has to be done for like every board at some point, right?
Yeah, we need to ensure that all the supported boards by Riot can actually use this mechanism of image loading. Yes.
But we could start with just one board. And
Yeah, of course, of course.
Yeah.
I'm just trying to point out, like, if there's a point where we need help from people, you know, this is one of the places where quite some changes are necessary. And yes, let's first try one board, but at some point, you know, it's nice if it's not only in December 21 where we can do OTA.
So, just one question on December 21, where if we have a prototype that works on this board, how is the CPU unit? Is this thing already implemented for December 21?
No,
I mean, I'm talking about the CPU unit.
Yeah, on the December 21, it's not an issue. There we can simply call it twice, once in the bootloader, once in the firmware itself.
So it's already in the bottom?
Yeah.
Yeah.
That's, I mean, we have, let's say, by good design, some of the CPU units are already like that, but we need to provide a test that will actually tell us which ones are.
I think at least the EFM32 boards are problematic.
Yeah, for instance.
I think they crash if you call it twice, and it's some kind of SDK call that's problematic, if I'm right.
Yeah, they initialize twice some peripherals that are not even needed to be initialized for the bootloader case.
So then, following Casper's feedback, is it something that is a showstopper now? Or?
No.
Okay.
No. This is you know, eventually.
Okay. So how about we have some showstoppers first? Then this might kind of streamline the discussion.
Right. Showstoppers at the moment is a bit hard to mention if we have already a working prototype.
Well, showstopper is like to have something in master that's going to work for like a few boards, and then we can expand from.
Right. For example,
what's the?
It says OpenOCD, but we don't need to flash the SEMA21 with OpenOCD.
No, but actually there is already there is this PR that was merged. I don't know, where is it? I don't know if it's mentioned here. Yes, this one, Flash bin files. So yeah, the current approach is to, I mean, our build system generates ELF files. And these ELF files, they're big, we don't need to treat them. I mean, we prefer to use binary files because they're small and we know exactly where to put them. So the problem is that currently OpenOCD was not able to flash binary files. And if we want to make prototypes in our desks and we want to flash one slot or the second slot or both slots at the same time, or etc., we need the tools that provide this functionality. And they were recently provided by this PR. So now we can flash binary files in any place on the flash of several boards, specifically in SEMA21 and others.
But SEMA21 is flashed with EDBG, no?
That's the default, yeah. But because it flashes also binary files. But the most current approach, I mean, the general approach in Riot is to flash ELF files. But with this method, we are flashing better.
Does that answer your question?
Yeah, I mean, I put the OpenOCD up there because it was a dependency of the that green one. But like, yeah, it's not the SEMA21 to be
Now, the thing is that this is strongly related to how generically we will provide the images. Because if we are not able to treat binary files, then how? So
how mature is this PR?
It's already merged.
So why are we even talking about it?
No, because he asked.
Yeah.
Okay, but then we don't really need to talk about this, right? So then.
No, then yeah. About showstoppers, I'm not sure.
Yeah.
I don't think there's any showstoppers.
We're not call it a series show. So if you want to have like things we have to decide on is how to provide the bootloader with Riot, as in how do you build the bootloader, how do you flash it, where do we store it. I think at this point there is an implicit kind of request for support for multiple types of bootloaders. I think Alexander already asked something about USB. So different types of bootloaders is something that that would have to be decided on how to provide this, directory-wise, build system-wise. What do we have more here?
I mean, I think the whole thing's modular, as always with Riot. You know, we can swap bits in and out. And for example, like the transport can be different.
Yeah, of course.
You could replace it with Bluetooth or something. You could replace the bootloader. Once we get an initial architecture merge, then we can swap. We can for example, implement MCU boots if the user wants that, or we could, you know, implement other stuff later on. You see what I mean?
Yeah, yeah, I understand. I think I understand what you mean. My statement is more about like how do you want to present this in the current repository, and how do you want to provide this? Like if we have multiple bootloaders,
Yeah.
Is there going to be an example for every bootloader just to put something out there?
Yeah, probably not.
I don't know, maybe. Those are things to decide on and things to what we want to take into account for this. You know, how far do we want to give a user the freedom to, or how do we want to present this to a user?
Yeah.
Yeah, nice to look to you. Where are we in terms of merged things? And
So in terms of what's PR so far, what do we have? I see like a few steps. So there's the producing of the images and the firmware. Sorry, in the bootloader. You have to produce these things, and then there's the commissioning of the device, which is basically actually flashing an initial bootloader of just an image. Okay. There's the updates module inside the image, and you know if we have that, then we're already pretty good. So if you decompose like this, like what is already PR, what needs to be PR, and what's
if I'm completely up to date, I think most of what's PR now is allowing for the multiple slot images, the linker offsets inside the build process. I have to think a bit. Is there more that is? Am I missing something here?
No, the most recent PR was build system related.
Yeah, so most of it now is build system related. Yeah, needs to be done at some point.
Yeah, the next PR that I mean currently we have the working branch of this. It's a work in progress branch, which has been rebased to master recently. So it has all the PR that were already merged. And the next step I think is to provide pull requests for the bootloader and for the metadata format. So that's the next step.
Yeah.
And once this gets in, then we can start to think about the OTA in itself, the process of fetching images.
So it's for the metadata, then are we going to use the correct suite?
I'm planning on that, yes, to have some kind of suite module with an explicit, you know, draft number there. Like this is the draft number we're supporting now for.
Yeah, this is the most simple metadata that we want to provide.
Just to clarify, this is metadata that is stored within the Flash to indicate that there's an image here. This is different from the suite manifest, but some information from the suite manifest is used in this structure. And at the moment, this is like the most simplest version of having some kind of indicator that there is an image there, a version number of this image, the start address, and then checksum to validate the metadata structure itself. And if the application or the update method likes to, there's probably some space left for additional information, metadata that would need to be stored.
Yeah, currently we have a space of 256 bytes, but it's also flexible. It's configurable. I mean, if your metadata exceeds this size, it just needs to be aligned to 256.
If you would like to store a full Silk manifest in here, or some kind of JSON data structure, or anything possible.
And it's at large because you can only have the vector table in line.
Yeah, exactly. The vector table, I mean, the booting vector table needs to be aligned always at least 256. That's an M0 plus, and if you think on M4 and more recent, you need to be 512 aligned. But for now, it works like with 256 in assignment 21. I actually tested this with other two boards. One is the Summer 21, the other one is the IoT Lab. I think now you know because we had the beginner tutorial. The M3 board. It's also working on that one, and that one is flashed using OpenOCDM. And the third one was a Nucleo board. So let's say roughly we support more general view, the SAM devices, SAMD21, which are from Atmel, and the STM32 from ST, which they have a lot of CPUs. They provide with a lot of boards, and if it works in one, it works in another. I mean, it needs to be tested, but I tested so far one. It was the STM32L1. That was the one that I tried, and it works.
Okay.
Yeah. No, I think the discussion that maybe needs to be more is in the part of maybe the transport layers, or I don't know. I mean, on how to decouple these the modules from, because this was not done so far. I mean, the decoupling now is from the build system part, the metadata part, the bootloader part, but on the whole, let's say over the air module, it's only like that. But I don't know if it needs further work.
More like abstracting away like the transport?
Yeah, because now how many modules you have? We have the OTA module, which is the one Caspar wrote.
There's like there's the OTA module and there's a Silk OTA module. So that's two different ways to, two different formats to deliver that image. There's for the Silk OTA, there's a separate CoAP module to get the manifest, to be able to receive the manifest. But the whole system of getting a firmware and actually flashing the firmware is decoupled to provide like a modular interface for what kind of the system or of the wire system you require.
Where are like CoAP servers? Have we got any other CoAP servers that we've implemented in the Riot main repo and like any other projects? And where do they usually reside? Are they usually in like examples or stuff? If we use Nano CoAP to make a bunch of CoAP endpoints for any reason, you know, because I guess it should go there.
Well, there is a suit one.
As in expand those examples for this, or
no,
what exactly?
In terms of where talking about where we put the transport layer code that's OTA specific. Well, it's basically a CoAP server, right?
It's a core handler like it.
Yeah.
Yeah. Okay.
The transport method is indeed as Caspar said. It's a handler, and if you extend your Nano CoAP, your CoAP, and what's it called again? The CoAP endpoints. Yeah, endpoint. The list of endpoints. If you extend them with your handler and you add the module, then you have your functionality for OTA updates.
Yeah, currently it's based on Nanopore.
Yeah. Which direction do you want to take it?
I don't know.
Yeah. I can talk more about.
If you have some questions to like,
The metadata is not including the public key.
No,
No.
The metadata is signed by a private key, and then it's verified by a public key on the device.
The device itself already has a public key flashed on it. So the manifest is signed with the private key that belongs to that public key.
So there's a commissioning step at the beginning, right? Where the software maintainer is going to flash the device with like a bootloader and like a first image.
Okay.
Okay, and he signs he's signing everything with the private key that is baked into this first commissioned firmware. Okay, and then when an update is downloaded, then it can use this public key that's baked in its firmware to actually verify that the new stuff comes from the same source. And this metadata that is being standardized with this specification is actually covering a range of tempering vulnerabilities with this signature on top of it, you can mitigate these threats. Is this clear or?
Almost.
No, maybe the other people already understand, so I can think about that myself.
We can talk
Yeah.
about
That's what this session is for.
Yeah, we can still have discussion.
Yeah.
Maybe I would make a call for, for the people who actually are doing right now some kind of IoT, that if this procedure it fits to their applications, I don't know.
If there's anybody here now who thinks I absolutely cannot use this for my own device. I know it's using CoApp, right?
No, I just want to use it.
Yeah, well then I think the next step will be like securing the transport layer, but that's like super further steps. If we're using DTLS or not.
So yeah, then there's also Ostcore that might be maybe a good example. The Stute version is already using CoC.
Yeah, the Stute version is using CoC to protect the manifest itself. If I remember correctly, there is no there's no real specification, I think, on how exactly to encrypt the payload. So there's a possibility of using Ostcore for that. At the moment, this whole plan doesn't take encrypting the actual image that is transported into account. So that would be a way to improve it.
I would say just in terms of like people who want to use it immediately, the development branch is like fully functional and does work. The problem, the reason for breaking it down and all this stuff is that it's been difficult to merge it because
You've attended the
session and stuff. But what we're going to do, like I say, is have a branch which is an open PR and which will be kept in a working state even as we merge bits of it by rebasing, so that you'd be able to use that with the caveat that it's not in Riot Master, and eventually it will be merged fully with Riot Master. So hopefully that'll satisfy both people who want to use it now and also enable as to get work.
Sounds great.
Good.
How do you select which image you want to be?
Like in the bootloader,
Yeah.
which the image with the newest version is booted.
Okay. So how is the drop the image doesn't move because of something?
There is, at this moment, there is no way, if the image doesn't boot, there is no way to roll back. There's the assumption that you've tested it very well and you know exactly what you're doing, and if you update it.
You don't have no bias.
Yeah.
No, I'm joking.
You of course first deploy it on a device on your
Do you have
desk.
plans for that, or
Sorry?
do you have plans for adding rollback?
I have to look at you for that.
Yeah, actually, I think we would take some of the inspiration from MCU Boot. They just mark they have a mechanism to write. I think at the end of the well, it doesn't matter where.
Yeah,
Mark if it's a testing update, if it's a production update, if it's and eventually the image itself can mark itself as a running image. So yeah. I mean the mechanism it's quite simple. So
yeah.
it's just an extension of the current bootloader, but it's not. I mean it's not there yet.
No, I'm asking because from my experiences that during the development phase, when test team is also testing OTA and stuff, they will get broken images.
I know that
my
my
way to roll back in other means than just reflashing the device with the data.
I know that's my first answer of things will be okay. That's a very naive answer. At some point it won't work anymore.
One question about the 2 slot sizes. Is there any kind of provisioning for having different slot sizes? Because I used to have an application where we didn't roll out 2 slots, but 1 slot that could do recovery, and 1 slot that had the full radio stack but not full application, and another slot for the application, so I could at least get into some kind of recovery mode. Is that something that is kind of on the roadmap?
For the roadmap, I have to look at you again, but I know that the current system is 2 equal slot images and you switch between them. There's
You can do
no.
that with MCU. It's called a split image, but then you need a support in your application as well.
Sure.
I wouldn't call it technically impossible to do it, but you
Yeah,
can put it on the roadmap if there's a request for it.
Yeah, currently our approach is that we have very flexible linker scripts. Actually, the linker scripts just take variables, and as long as you provide the variables with the right sizes of the slots you want or how many you want, the division will be, the compilation will be done that way. But overall, I don't see anything that could stop to do 2 slot, 3 slots or more. Currently, we do 2 because it's the most general case. Only because of that.
Further questions, comments on?
Yeah,
I'm also a bit unsure.
Yeah. How big is this code? I mean, how much flash is needed for like parsing all this in the application? If I have my image that takes, I don't know, 50K, how much will it grow if I add this?
So I just compiled it. Well, this is the bootloader.
Yeah, so the bootloader is quite small, but if you add, the complicated answer here is of course that it depends a lot on your application itself, because the suite, the whole stack as is presented here, it uses CoWeb, it uses Seaboard, it uses, well the suite is obviously new, but if you already need an Seaboard parser, if you already need CoWeb, then it's only like the crypto maybe, unless you already need crypto. But if you have like an application that is just a sensor display that doesn't need networking, then yes, it's going to add a lot to your stack. And I think we're talking about 10K flash extra longer slot.
Yeah, for instance, that one is your example. I don't know exactly how much application code you have.
So,
Server
crypto, Seaboard, Moab, Template, Flash. So how about answering this like first the other way? Assume you have already like your application already uses CoApp and basic crypto. What more do you need? That's a good question, right?
Yeah, yeah.
Okay, so assume like it's the baseline scenario.
If you, yeah, it's a code resource, you need something to write to the Flash, because that's not something your usual application has, I think. Yeah, you need a Flash driver. And an actual suit parser, but that's
How we do that?
Can you just like make up object info, object size, info object size?
To the suit.
Just port equals semi21 and then make info object size. Yeah, object size of object. OBG size.
No.
OBG size.
size.
Info size?
No.
Size.
OBJ size. Yeah.
That's my. Oh.
Okay, and now scroll upward.
I hope my claims are correct.
It's
I mean,
know
it's
how
like to
this
say
works.
there's Seaboard parser, which is like
Suit is keyboard, suit.
it's a lot.
Yeah.
What the hell?
It's a lot of if statements. If an
Yeah,
if
yeah,
an-
I know. That's why I asked because
Yeah.
MCU build we are using MCU manager that was open source and stuff like that, and it takes more than 10K. That's why I was surprised.
Yeah. Which is what kind of keyboard library are you using?
Tiny Seaboard?
Yeah, this is also Tiny Seaboard. Tiny Seaboard, in my opinion, if you compare CN Seaboard and Tiny Seaboard, then CN Seaboard is very nice for your Flash usage, and Tiny Seaboard is very nice for your RAM usage. But it's a trade-off. But in this case, it's mostly, I think, validating whether your struct is valid to receive.
So is he like 6K for tiny Seaboard?
Yeah. Tweet salt, I think here is
Yeah, that's the one.
8.6, but I know you can get a crypto ED255.9 for a bit more than 5K.
But it's
What
different.
do you use for crypto?
Here it's tweet salt.
Which one?
Tweet salt.
It's the second largest probably.
And what crypto is like? Did you have a asymmetric?
Yes, it
It's the ED255.9 signature scheme.
Because Tiny Crypt can do it in 4K.
Probably.
I'm just.
Yeah.
You can even see that.
I also know that I think
It's not the same signature scheme.
no.
It's not the same.
No, that's TinyCrypt is ECDSA, I think.
Yeah.
Yeah.
So cool.
There was a result, which was solved with like market controllers that might have been more optimized.
I think.
Yeah, I think there's a package for that. You just have to select that instead of free.
So yeah, it's the same interface. I don't know if it's still maintained or
If it's the Microsoft one, it's mainly optimizing the handshake. And not
Like, it
the
didn't improve the signature speed.
no.
Yeah, we were making some benchmarks with this, and
Yeah.
actually Kun was making it. And
Yeah.
some of them are not. I mean, there are trade-offs.
There are better ones than Tweetsalt, crypto library.
Hello.
Hello.
We do support ED.
Is there already a package in Riot for you?
If my pull request goes through, yes.
I should just press merge. Thanks.
I'm calculating which size we have for that because I think we can do better than Tiny Crypt.
Awesome.
So I have a question about this. Like, do you, if we just use the signature, can you configure your package so that it's modulated the fact that
That's what I'm working on right now.
because that would be very useful for
Yeah, exactly. No, no, no. I want to do, especially what they say yesterday. So we can get this granularity that each package is compiled its module. So I just your potentially your bootloader will depend on WorkScript and WorkScript ED to.
That would be awesome to have.
That would be great. That would be great.
I'll keep you posted.
Cool, thanks.
Yeah, I think it's just a API thing that we need to be like interfacing with any crypto library, and then we can.
Yeah.
I mean, the only thing we need is to sign and verify.
We like competition, so I would really like to know how better we do than TLS, and if we can actually do better than TinyCrypt as well, because I don't know TinyCrypt, so I can't do assumptions here.
And actually, like, the only thing we need to do in this scenario is just to verify. That's it.
Yeah,
We don't even need to
it's
sign.
pure
Yeah, absolutely. Yeah,
signature
yeah. So
verification.
just a verify function. Okay.
Yeah.
I'll keep that in account.
Yeah, because the signature can be done using any other tool in the server. I mean, the server is powerful, so.
Yeah, the only thing that you need is you need to verify function.
If you want to have a timing estimate, TweetSolve on a Cortex M0 is like 7 or 8 seconds for signature verification.
I think
Yeah,
it's super long time.
and 0 plus 4 seconds last time I checked. But I can give you better measurements if we target the same board.
Which one?
The 82559.
Yeah, but like, the benchmark we did take 4 seconds. I'll do it first.
I think if you have the right one, it's 4 seconds. If you have the fastest one. But the 82559 is not fast on a microcontroller.
It depends on the microcontroller. I can't remember which speeds I was running at. So yeah, we can make, as I said, I really like this kind of benchmark, so I'm really open to this kind of competition.
All right. So we're looking forward to your PR.
Yeah.
It's also strong, which I think does stroke. Stroke. A stroke. Yeah, they might have that in there and small. They had that in stroke. Maybe. I'm just checking that.
I think it's becoming hype.
Yeah.
Because in the past it was not. I mean, I started this work like 3 years ago almost, and there was no. I mean, that's why we used TweetSolve, because there was almost the only one out there with small footprint.
At that point, it was the nicest option, and
Exactly.
nowadays it's.
Nowadays, even OpenSSL is doing it in their current version, and it was not 3 years ago. So it's like maybe more validated. I don't know. The thing is, I think it's not yet NIST validated,
No.
but which also makes it more secure. I don't know.
Depends on your perspective.
Yeah. But yeah, I mean, the crypto is yeah.
Are there any plans to maybe bypass the whole networking and just maybe use plain stereo to flash the bootloader?
Well, that's. I mean, the question about that is that which are the mechanisms? I mean,
If you want something like Arduino has, I think, it's like a serial updater, or.
I was just thinking that it's maybe a nice building block on a way to get it merged, because they're like just a test application that you feed in your image with a serial. Once you start a shell command, you can test the flashing and the bootloader part completely independently of crypto and networking. I think that would make merging fast.
but I think the next step is something like that. I mean, the next step is to provide the tooling to generate the metadata, which needs to go somewhere. Then the additions in the build system to stick this metadata into the binary file, and then the flashing command, which is already there. That's why flashing binaries was important. So once this is there, you can actually flash it using OpenOCD, and you can flash slot1, slot2. But the transport mechanism, I think, is clearly separated from this.
I think it's a valid idea to be able to at least use serial as an update mechanism, or
serial
different, or
whatever.
whatever you require for an application. I think for testing, serial might be very nice.
Yeah.
Yeah, because you can just run it on the CI and the networking, we don't have the infrastructure yet.
But
Yeah.
even with the current approach, you can flash slot 2, and of course it's like if you got it somehow. I don't know why this area is more benefit.
Because you can test the whole pipeline from the flash write module.
Okay, you want to use
For
Riot to flash it. Okay,
Yeah. We know that we can flash things on a microcontroller with OpenRGB, but we don't know whether we can flash with the module on the board.
Yeah, well, here's testing for the flash writer. I mean, it's, yeah.
The nice thing is that if you write an application that actually does that, if you write it nicely, you can use the same to provide serial upgrading with bootloader.
Yeah.
You mentioned that you will need a tool to do a metadata, so it's not part of the image that is going over the air?
No, not
Metadata?
like in the suit architecture, you have a separate manifest that contains the image information with the update. So it's manifest first, and the manifest describes where to get the image.
Okay, and the image doesn't have this
No.
structure in the metadata?
No.
So,
Depend.
how do you
With
know
with suit,
which
it doesn't have it. With
If you don't know, you're just assuming maximum size for the metadata, or what?
yes.
Oh.
Because you need to round it down to the what is it, 512 bytes anyway, to be able to actually boot it.
Yeah, so basically metadata cannot change. I mean, they cannot grow higher than one slot, or whatever it's called.
Yeah, one it's the depending on your microcontroller usually is 256 bytes or 512, but
Yeah.
you cannot do like 90 because then the pointer of
I understand, but the metadata part, it can take only one page or one flash page or
no, it's not one flash page. It's far less than.
So, but what I mean is that you need to know in advance how big the metadata will be generated by the firmware to have a proper address. Right?
Yeah, exactly. And this is
there's a start address in the metadata itself.
Yeah, but you need to know either the size of the
You
metadata.
need to know the maximum size,
Yeah,
right?
yeah. But it's given. It's as a variable. That's why the metadata can grow as much as you can.
Yeah.
Okay. So I'm just asking because I think we could probably add suite support easily to what we have to MC Manager. But we would have to create the metadata upfront on the server side because of there's it's combined with the image, right? In the MC Manager.
Okay.
Yeah.
So we're a little bit running out of time here, so we have to wrap up. I think there was like one last comment about like this serial step that we could or should consider.
Yeah.
So how does this change like the potential next steps?
The serial update is actually on that dependency graph, but it's not a dependency of anything else. So it's more of like expressed as a kind of nice to have. But I don't think it talks about it as a useful prerequisite.
So that's exactly my point. Like if it's something not nice to have, but it's something we want to have as an intermediate step, then how does it change? Like, is it something we can already
kind of down a bit on the bottom.
Yes,
it's there, up near the top now. Middle left.
Oh, here.
Yeah, exactly. So it's hanging there, so it's like, it's not even.
This is an optional feature.
Yeah, something like that. But then, it would be useful.
You would need a flash driver for it, and at least, and if you want to do it with by the bootloader, so you have a bootloader with a timeout, and as soon as within the timeout it gets something of serial, it would require a flash drive and bootloader support, and a bit of a protocol design to push over the serial driver. And I think that's it because you don't need crypto.
I think one thing that is missing to just show properly is the dependency of which features a board needs to implement to be able to use this approach. And this is written nowhere. So maybe in the issue I would write just the minimum requirements, which is, for instance, one is there, the CPU idempotency, for instance, this is a dependency, and the flashing drivers, because I think we have this the flash page write drivers. We have they're not implemented for all of the boards, and especially the STM32F4 have a flash map that it's a pain. So it's very complicated to divide it into even slots. They have a memory map that is super weird, and we don't have a flash driver for that yet. So yeah, currently that might be a stopper for the broad support of OTA on the devices that are supported in Riot, at least for the Cortex-M series.
But this is something that's not a showstopper, right?
No, not for the prototype.
No.
I mean, the prototype, anyways, it's there and running, and there is nothing that is missing, let's say. But for other people, like if they want to use it in several different scenarios, they need to be aware of which are the dependencies.
For the prototype, it feels like not really showstoppers, but things that take time is just getting PRs merged, getting them reviewed, that whole process, deciding on what is that bootloader structure. Those are, I would say, are the things that just take time. But serious showstoppers for at least on the summer 21, I would say that there are none.
Okay, so we need to wrap up now. So yeah, thanks for participating. And as you see, like there's quite some work left to do.
Where is the PDF? Can we? Is it online?
Yeah, I think it's almost online.
Oh,
yeah.
It'll go up early next week.
Okay.
I'll update the
So yeah, I guess now we understand a little bit like what we're aiming for as an initial step, and then help is always welcome. And, yeah,
great.
Thank you.
Thanks. So, I have one question. What's a bootloader?
Bootloader, what's a bootloader? It's like Riot, but with very few modules, so it's even less than GNRC minimal.
A short
Does that answer your question?
And then the next step is like configuration here and PRs.
If anyone's interested in us on Riot, ask them to give us a demonstration of the configuration.
Will surely be a lot of comments, and sometimes people will raise issues and repeated issues. But I think it's if we do the paper, then there's the chance for you to have a voice. Then, so yeah, use the paper, please. So then we can have everybody's thoughts in one place. You have the opportunity to participate.
Yeah, and also one of the things, like even if there's a repeat idea, it would be nice if you can also write it down, because then if we see there are a lot of propositions that have a lot of weight, it might help us to prioritize the problem. So feel free just to write it when we go to the problem identification. Okay, so somehow the main goals, a little bit of context, like a month ago we sent an email about some issues we were having with different topics related to configurations in Riot. Basically the way how we configure build time stuff, how we configure the metadata Riot, how do we integrate like different hardware, and how we describe the hardware now in Riot. So we sent an email like 1 month ago. We came up with a task force. We have been trying to identify the main problem, but of course it's much better if we are now like the community here and we can discuss this kind of problem. So then if we have to go to implementation, we have the discussions that here. So one of the main goals is expose and discuss the problems we are already having. And also we would try like to come up with a proposal for a very high level, like what we should focus, what do we want to focus, and so then we can just discuss about implementations via GitHub, email, but when we know like what we want to solve. So next. So agenda for now, we will have like a small round for identifying and prioritizing the problems. Also, we did some research about what other people are doing. I think it's also very nice like to know this beforehand, so then when we come with our discussions by GitHub or whatever, we at least have a clear picture of what's missing, what we do really good, and then we have more information for taking more decisions. And also like try to discuss like different approaches for configuration. If there's time, we'll see how it works with the problem identification. Next. So we have been discussing this like by the GitHub issue. There are some ideas of what kind of problems we have. We have already some list here, but would be really nice if we can start like if we open the discussion here and people start asking about what problems they have about configurations. So we can then continue like with other stuff that the community has spoken about. But it would be really nice to start enumerating this kind of stuff. Remember to do the +1, we have post-its here, so if there's a problem that sounds interesting, you can do like the +1 and we try to detect like this kind of problem. So anyone, it's open like for one of the configurations problem we're having now before we can read what are in the emails or whatever.
I can start, so so that people listen up. Just to give an example, I was trying out this sensor on Monday, so I got the STM32 discovery board. I look at the documentation in the Riot docs, and well, I was praying that the I2C that I needed was mapped in the default configuration for that board, because if it was not mapped, then it meant that I had to go and modify a header file, which meant that I had to make a new branch of the Riot. By the way, I was doing an application in a separate directory because I didn't want to make a branch of the main repo, just too big. And of course, it had some exposed I2C pins, so I didn't need to modify anything, but I think to myself, oh, well, if I had needed something else, it would have been necessary to go and modify the header file. So that for me is a problem. I know if it's a problem for somebody else, like changing pinouts of ports.
Yeah, but you can write to go over this problem. So the perifconf.h file, which is in the board, it's given as the default version of the configuration. But you can overload this in your application directory. So you create the same file name, you copy paste it, or you copy it, and you edit it. I agree, it's not super nice, but you can use the main Riot code and just get inspiration from the initial one. And if your application only need one UART, you can remove the other that you don't need. And
over there.
to respond to that, I think yes, that works, but I don't think it's very friendly solution to copy the file. From a beginner perspective, I would rather, turn it off than let this fixed, and I think that's also what one would like to do.
Yes, I think we have like a partial solution in the queue for that, because right now this tariff path is pretty static. You have to copy and copy paste modify it. But all the actual configuration, they are like arrays, and we're going to have these crossfire arrays. And using those, which just one simple line, it's very possible to have in any C file, maybe in your main C, just add one line for you as just you want it. So how the line has to look, it's still like probably we're going to figure out how to get that information, but it's going to make it much easier to have a dynamic verification.
Don't get me wrong, I don't want to argue against changing anything, because I think we all agree it's not really optimal like this especially board configuration is. But as a background, I mean, what you were talking about, it's a typical evaluation board thing. You have like tons of pins that are exposed somehow, so you need to kind of wiggle them together to something. And I mean, one of the main use cases in Riot has been to run like on certain products, right? So you have more or less custom boards that run certain configurations, and those are more or less static because they're soldered together. So the driver, like years ago or something, to have this kind of configuration was always like on most boards or production boards, you will always have a static mapping, and it's partly true, I guess. So yes, let's see if we find something nicer.
Hello. Yeah, what I'm thinking about is at the moment it's quite cumbersome to use certain command line arguments. So, for example, the boards are not very human readable. So, like every time I build for Finode, I still have to look in the boards folder to install something like PWKX.
No, PBA.
And the other thing is when you have multiple boards, looking at the serial port, you have to do make list TTYs, and then you've got a big long hex string for your device, which you've then got to copy and paste, which is really cumbersome. So it'd be really good to be able to quickly build for different boards and just go really quickly, especially with like multi-board setups and stuff.
You write it down.
Yeah.
Matthias? Yeah, another problem I was encountered by a guy who's doing some rap with us. It's also for kind of beginners to find the correct configuration or what to do to get my application running. For instance, his problem was he has a Nucleo and he wanted to use the MRF transceiver, and he just flashed C networking, and then he was complaining, okay, I don't see a network interface. Okay, you need to use module MRF. So he did this, and then it's not working anymore. It's still not working. And even I needed to think about, wait, there is this MRF _ params default configuration, and you obviously need either for your application or need to modify it. As Glenn said, we need to go in there and then we say, okay, this is the Nucleo I use. This SPI with this CS pin, this reset pin, and this, I don't know what else you need, interrupt pin, or whatever you need to configure. It's very hard to find and see, for at least for a beginner, what to. So maybe also the keyword is maybe to expose or to make it easier to access the configuration. It could be like if I do make on GNC networking, the make program could already complain, hey, your board doesn't have a network interface. You really want to put on GNC networking. And if you put in use module MRF, it could say, you want to specify a configuration. It could ask for a configuration. I mean, maybe you just click through or go even on a shell. You could say, okay, well, I want to use SPI 0 and then the CS pin and something. Maybe at least for a beginner to expose it a little bit more, make it more obvious what to do.
I think I have a problem very often. I have the Nucleo, and then I want to connect the driver. So I connect the two pins on I2C, and usually I have the Nucleo reference manual open and the data sheet of the STM, because it's super hard to map the D4 on the Nucleo to the PCA port CA on the actual MCU. So I think we need some kind of mapping there.
Behind you. There's also a variety of that problem that comes up when you use any kind of model. Boards and they have to be some kind of defined positions, and then you not have a pin, say port 4, but that's actually D16. But you'll have the reset pin on slot 4, and you'll actually want to start Ethan, for example, start this or that driver on slot 4 of that board, and that's a variation of that, which I think we might want to consider if we're going in this whole direction of having not complete finished boards, but boards that are still worked on where the definition is not completed.
I got one. Somebody else here, or? Like, not really to pins, but I have another issue with. I mean, it's not super big issue, but it's certainly uncomfortable to work with. Is that I want to change something, some configuration, like build-time configuration in a module. So I go on the makefile, I change the C flags, or I change I define some variable, and then because I change the makefile, the whole thing gets recompiled again, and that's kind of annoying.
So I think there is also, for configuration, there is a level of configuration that should take into account. It's the application level. So that's what you're saying, but the board is providing the default configuration for the CPU. So how things are mapped from the CPU to the board. So we can think of some Nucleos that provide 3 different UARTs. So you have the first one, which is connected to STDIO. You have 2 others. But the thing is, if you build Hello World, to this application, you don't really need the second and the third UART, you just need the first one. So why don't we drop this from the thing that will be built in the final firmware, so you save a few bytes. So I say that, for instance, I have a PR about the low power UART on STM32. I implemented it for L0. The thing is, for this one, I have to say, this board provides LP UART and UART. So then the LP UART support is built in all the firmwares that use UART for this board. But I only need the first one, so Hello World is increasing its size because it's building some other extra code for LP UART, although it's not used. That's something, so we could save a few unnecessary bytes in the firmware. I don't know if it's clear.
Well, I also think, like for instance, the way how we keep some really end-user information on the nodes. For instance, like I had this problem a lot with LoRaWAN keys, where I did like a generic LoRaWAN application, but if I want to distribute it, it's like, how do you handle to write the keys? Of course, you can always have C flags, you can always have makefile stuff, but the problem is what happens when you have a lot of applications and you want to find a way, as I said before, even like exposing what can I configure there, how can I deal with the I don't know, default configurations, how can I override configurations? I think that's also, yeah, that we could solve, it could give a lot of value.
I think it's important to consider the fact that, you know, with a lot of IDEs, for example, in industry, the build system's already set up, and you don't need to know about makefiles in order to write software. For example, for Kyle, you know, you just have, you just need to know how to code in C. And for us, you know, in order to build anything, people have to go into the build system and go into the makefiles, which for some people might feel somewhat inaccessible. So I just think it's important to consider the case of people who don't have to care about the build system. So I guess I would say problem is requires currently some familiarity with make, whereas a configuration system would remove that.
Okay. Yeah, one problem I found also when configuring like how things should be built is that, and again, it's annoying and it's kind of breaks like the encapsulation of packages. Is that I added some modules or packages, and then it's not only like writing the C and the headers for the package and the makefile, but that's kind of the three of the three together, a C and an H and a make. But then you have to go there in the other makefile and makefile.deps, and you have to like contaminate other lots of parts of the system in order to add a new code. So it's like one package, the configuration and the dependency management of one package is not separated from the rest. So it's kind
I
of.
don't understand. If you have a package, a package has its own like makefile.dep file. It has 3 files, but they are contained in one folder.
Oh yeah, oh sorry, a package, a module. Yeah. So this before we start like trying to discuss solutions, we think that it's valuable to take a look of what other people are doing, just so we don't like reinvent the wheel 1,000 times. And well, because there are more or less successful projects, so well, they must be doing something right, at least something.
And I think it also like the moment where we're all gathered here, and most of the discussion we come up with now can be just addressed later on GitHub, dev list, and it would be nice at least to be like in the same wavelength, and then we just go on.
Yeah. So.
Yeah. Hello. I mean, we just took a look at some like different approaches and maybe like an overview of our systems, how to handle some things. For example, the Embed OS, some key features. They do a customization in compile time by generating some code, some header files. They typically define the configuration in the configuration in some JSONs for drivers. They call it like libraries and different modules, CPUs. One thing that they have, it's like they have like this command line interface that well, someone addressed here that it would be nice to know what configurations are there available to modify. So you can just access them. You have like some information about who requests these configurations, if it has a default value, has a description. Also, you can override some parameters depending on your target, just in application level. For example, I know something like maybe what Dan said, that he might want to build for different targets, different ports at one. I mean, you can just define in one file different parameters for different builds, like in the application layer. And also application can override the different configurations. We will see then how these inheritance or overridden parameters are. So this is like the order. You have like targets that have some default configurations. Then libraries can override those parameters, and finally applications override the other two. Configurations have like this look, just regular JSON. Sometimes you can just say that, hey, this package module needs some parameter. I'm not defining now, like param2, but in build time, you will have to need that parameter defined somewhere. And here it's like, for example, a configuration on the application level. You can just access different modules by this syntax, like mylib timer period, for example, and just address different targets depending on your target build. This is like some key features that are defined in the target configuration. For example, the device has just expose what the hardware has there. They do like some differentiation between the MCU and the CPU and then the board. So you can just inherit from your family, then a subfamily of CPUs, and then the MCU. Like keep adding things to that first configuration. So you can define the core, some features. Device has is just like, okay, this has I2C, ADC, SPI interfaces, some supported tool chains, and you can also define the macros for that build. So this is like the differentiation. They have like families of families, MCU and boards. Well, just some conclusion. You can modify configuration in different levels, and as they use some kind of parser, they can verify that there are not conflicts between names of parameters. Maybe you can just see if these parameters interfere in different modules. Well, we overlooked some key features and so far. They're using for hardware description, device tree. So they basically have like a CPU description, then they can include the CPU, the MCU description into a board description. And that defines basically what hardware is available and the boot time configuration of that hardware. Basically, for the software and the features that included, and the final image configuration, they use the kconfig. And also for configuring the build, they use CMake, and you can build them with Ninja Make. So device tree can include, like I said, the architecture and the MCU are different files, so you can reuse them. And they also have to define, for example, the memory banks and the way you have to flash that board particularly. Well, some conclusions, like the last one, these exposures the available configuration, but in a different way by using kconfig instead of like the embed CLI. And they use like some sort of standard method to define the hardware, like device tree, and make this clear distinction between the CPUs and the MCUs in the board. Well, we're talking about maybe someone talking about this one. Just we added to someone we didn't use it, so there was the guy. Yeah. Okay. Let's keep it.
Just to say, they have a tool called
I used it in the past. Yeah. Hello. Yeah. Yeah. Basically, they have two options. One is using YAML files. So basically, in the YAML files, you describe what you need to know beforehand, which kind of parameters you can configure. And yeah, it's basically super descriptive language to see which kind of features you need. And you never have the repository already in your machine. It gets fetched by the tool called Newt. So this is a kind of very concrete tool to manage this OS, and it does build system configuration and everything. So yeah, that's a drawback. Is you need to download and install the tool.
Some notes about Contiki NG. They use header files and just make file variables a lot. They have something similar like Riot. They use this module variable to point to the modules pathway to use, and most of the network stack and kernel configuration are done in that way. Not much to add there. Maybe package management. Yeah. Okay, we just look at this C++ package manager just to have an idea how to handle maybe external packages, because that would be like maybe a conversation we would like to have a discussion here. Well, you can install packages just by commands, like you would expect. They are defined in JSON file where you can say, okay, this package depends on these other packages, and they need at least this minimal version to work. And well, all packages use the bulk build system, and most of them have to be adapted to work with that. And you can have a receipt on how to import that package. So I mean, it might be done in different ways. For example, well, this is like the description part of the package, and the receipts have, like, for example, I know for this version of the package, you have the URL, you have that hash, maybe a subpath, and if, for example, the package on the source file on the first address doesn't have like the back metadata of the package, you can explicitly say like, okay, well, you can fetch that back information from here, and this is like the dependencies this package have. Like, this is the version, and this is packages you need to install before. Move to do part of this.
Well, and decided also to do it. Like, I have this like acts as a source of inspiration to get like even like new products that maybe we're not aware of, and also like to see how we could approach now. Like we have like a little of problem. I'm pretty sure there are some other stuff, and it would be really nice if something about other systems could make sense. So if we could try at least like, I don't know, like one of the directions we just exposed. So then we somehow know how could we start prioritizing and try to take small steps from there, but when we have like the whole picture. So I don't know, like anyone like wants to. Okay.
Yeah. Yeah.
So I guess there's a typical way of doing things in Riot. It's always try to, of course, go in like small iterative steps, get small things done, make the situation better in small steps, with hopefully like a larger scale goal in mind. But did you investigate any more in this idea that we presented? I don't know, some developer around. I don't know where it was, when it was, like some month ago. I mean, me and some other core maintainers for a while, we had this idea to at least start with something like all these configuration parameters that you identified that are like, you know, somewhere in the network stack, like packet size, packet buffer size, or like, you know, some configuration variables where typically always is if not def blah 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 value, then defined as some default parameter. So every second header in some sysmodules has these defines you can override on demand. And of course we agree that it's like really stupid to find out which define you need and so on. So I think one concept we were at least talking about is at least having, you know, some kind of prefixing these values to say, hey, they all start with config underscore something something, module name something underscore something, which would make it very easy to parse them, to go like write a simple Python script, go through the header files and, you know, extract all of these things. I think it would be even possible to put it together with the make system somehow to just only pass the headers that are actually included in the modules that you use in your current builds, so you're not overwhelmed with like all the configuration options of some module you're not even using in your application, and simply extract these into some kind of configuration file. And the format is to be discussed. It doesn't matter if it's an extracted header or something, from which you could just generate some makefile you could include. And then you could just edit the options, or at least you have an overview which options are all kind of possible in your build, and you could easily at least adapt some of them. And by just simply include this generated makefile in your application makefile, you already kind of included all the changes you do without having like huge command line arguments or like this cflex blah blah additions. I'm pretty sure it's like not the end of the line, and it's not the solution to everything. But it's a small step, and it probably makes life, especially for beginners, a little easier, as it makes it kind of quite obvious which options you can influence in your current build, and could give some more overall structure at least to some parts we have now.
On that same line with you, I think maybe it's also a great idea is if some if you can know which configurations go into which module or which package, and then you can also filter out those who do not, to keep no so you keep the isolation. My module cannot see every other module's configuration, which I think is much cleaner. One question that was also presented, like in the in the mailing list, I think Caspar wrote a mail to, is that something similar to what you said. Is do we go from the top to the bottom, or do we go from the bottom to, like, do we have a file that we manually write declaring things, or do we guess or extract the configuration from what we already have? So that's some question that would be good to analyze the drawbacks of each one.
Yeah, I mean, my first thought of how we might start is just by making a big list of everything we would want to configure, and then organizing it. So like we could literally just write everything down and then assign it, like write some attributes we want to be able to express, and dependencies and anything else we want to express. And then by working on this big list and structuring it, eventually maybe, well, eventually some structure will come out of it, and then we can pick tools and methods to express that structure. And that could be like, we don't do any technical work, we just have a live list that people add to and develops.
Yeah, I would like also to make clear. Well, yeah, I have several things here, but I would say first go bottom to top, because there are things that are not well done in Riot right now that avoid to do this job like just straightforward. Especially the dependency management is a mess, kind of. I mean, it works well, good, but we need to order things, put things in the right place. Then we can also, I would like to see if we can at least have in mind all the time to separate two things about configuration. One is building configuration, which means which modules I need for which application and how I will add them, because we need to configure this. And then the functionality inside a module, for instance, a channel, the radio channel of our radio interface, it's a configuration, but it's functional. And I need to be able to set it before I compile my application. But I also need configuration for the build system to, I don't know, to know, I don't know, if I add 3 drivers of radio, I will have 3 interfaces, which now is possible, but it's not expressed in any way. So first I would say we express the configurations that we need in some kind of non-intrusive way, as Hauke was proposing, like some header files. I will even separate the header files in other files, which are not intrusive. Like you can add them and they don't hurt Riot. Riot still works in the same way as it does right now. But you can parse these configuration header files by a tool or whatever, on which you have explicitly which kind of configuration on the modules you can have. And in another kind of file, as Caspar once did for a new build system approach, more different expressiveness in YAML files, on which you were explicitly saying which are the dependencies of this package and how it needs to be configured to work along with other applications. I mean, it's kind of software composition approach. And the thing is also that this will allow to beforehand know if an application is actually valid. I mean, you don't need to compile it to know if you have all the modules you want, but if the dependencies are not met, you can actually know it beforehand and say, not even build this application, it won't work. And also with configurations, if you put a channel which is 26, it's valid, but if you put 30, you know that it won't compile anyways. So all of these things can be verified by other tools in a high-level approach, and they need to be exposed. So the easiness of expose the configurations, I think it's crucial at this stage.
One thing to add to the configuration macros thing that Harvard proposed, and you also further talked about, might be that in some packages they have something like that already. For example, in LWAP there's this LWAP conf, where you basically configure your stack. So there we can't just rename them by config, but they are valid configuration parameters for your application. So there needs to be, like, on top of this very basic solution, there needs to be also another more complex solution that also especially for packages, finds a configuration for that, which ideally would also scale, so that a package maintainer doesn't have to add new options for a package when there are new options added to the package.
Maybe one point to add on this is, like, when we do this configuration stuff, when we think about, we should still keep in mind that it should still be easy to, I mean, it's not possible right now anyway, but to drop in or pull out a module and throw it away without changing any central files. So I think like for the packages, they have their own, it lives inside the package, and so should the configuration for module also be or stay in the close to the module, not like that we have like a big central Riot configuration file. Then where we specify things, this might be a solution, but then you can't, like, just remove a module or put in a new one without editing another file again, which doesn't have anything to do with the module.
For me, in that sense, the ideal situation is you have all the module or board or whatever contained into one directory. You delete the directory, boom, it's gone. You put the directory again, it's in again. And
exactly. Yeah, that would be nice.
So you touch anything. It will also make life easier for everybody that wants to add external things. Because right now, external package, you can. I think external module after Gaetan's work, you can too, but not everything can be external. It means that you have to make your branch and put it there. Another thing, because we touched on that topic before in the maintenance session, is that if you can have what you are describing, then you could easily have an old and a new version of the same package. So that would be a possible solution to people that want a new version of this package, but don't want, or maybe they want a fix. Don't want to upgrade all the package at once. If you have version numbers, you will have incompatibilities.
Another topic that you just mentioned, which we haven't discussed here, is also versioning in itself. There was a discussion on the mailing list and issues like, maybe I think it's kind of configuration as well, that it was thought about all the time, like we never have any versions, like API versions that we somehow fixed, or, I think the core, everything that's under core is quite stable for the last few releases. Maybe some bug fixes, but in general, it's the same core that we use for several releases now, because I mean, it's core functionality that doesn't change, and it would be nice to express this somehow so that somebody that writes an application and he knows, oh, I use the Riot core with this hash or this tagging version, whatever, and I use the I2C API of this version, and then I check the release notes. Oh, okay, it's still this I2C version, it's still this core, so it's safe to update to this new release, or it should be safe at least. But if I already see, okay, no, the API version changed, then I just say, oh no, that might be a lot of work for me to update my application, so I stick with the right version, with the previous right version. Yeah. So versioning.
For me, it's a problem. Say I'm writing something and then I'm not sure if I'm changing it. Sometimes you want to change, improve it, but you're not sure whose code you're writing, right? It may be that the old version is okay, but you want to make an improved version. So then, that's where you change major numbers of the code. Every package manager out there has versions, so I think we should have them to be complete.
Yeah, and I also think in a lot of cases there's software that could work. I remember that the Riot sniffer at some point was broken because there were some changes in the Riot master. But the functionalities were there. If it's possible, like to specify what kind of modules we're using, at least we can provide like a stable version. And then if we completely rename the APIs, we can still use like old software. And but the problem is that we don't have control now on what we're building, on when it was working, besides doing a git reset and hope that everything works. And yeah, so I also think there's something to do with.
Yeah, it'd be interesting to hear whether most people would want to use config files or maybe like a GUI solution. Because like Ncurse is, for example, is a tool that allows you to easily write simple GUIs for stuff like this. So it could be, not too much hassle to do that. So I wonder whether it's a preference to write config files or use a GUI.
I think they're not exclusive.
Yes, that's a good question actually. When you have a well-defined config file, you can easily write a GUI on top. So, having the most important thing is having a well-defined structure. And which interface you use to create the structure is your decision. Right? You can use a GUI to write a config file, but you can also use it over the GUI if you write something. Yeah, basically the same thing. I mean, the GUI is completely. You can always put it on top. Yeah. So of course we should never depend on users having to use a GUI. I mean, I think most developers will agree with that. I think it's very important that we can see if we can make these things like at least not intrusive in the first place, in the sense of not forcing people to use a certain YAML file format, for example, or some JSON document or whatever. I mean, there's like tons of formats as we know. But how about, I mean, we can always follow a path in the middle that for one, I mean, in the end, right now it's about like, some environment, some CFlex parameters or something. And I mean, there's always this thing, this transition thing that you can have a nice YAML file, which you convert just into some, Makefile. And our computers are fast enough, they can easily do this with like 500 configuration parameters. So if you just convert it to some kind of Makefile, like our riot.h file, which includes a lot of defines, you can have both. You can have very nice abstract format with like conditions, and you can use a Python file if you want to, or like some other. But in the backend, you just have basically a mini compiler compiles this into a Makefile, and the build system is only using that Makefile. This way, you're not forced for certain tools, and then you can just simply, I don't know, design one tool which you like best, and if there's acceptance, people will use it. If not, somebody will come up with something else. But if the baseline, the core of it is just, something simple like a header or a Makefile, then we are not dependent on any tooling.
Well, I mean, for me, the thing with those approaches is I would think it's maybe better at some point to forbid people from doing things in a certain way. Why? Because at some point, if you continue to allow people to do to do define packages in the old way, it will get in the way of doing it more tidy way, if you want. Point being that for example, one problem we had in the App Store is that we wanted to allow people to upload arbitrary code, just their files and their make file, but then we have a builder, right? And the problem we had is that the make file is so general, and there's so many things that can be done that we need to manually review what's been uploaded because they could run arbitrary code in our builder. So that's a problem. So essentially, yes, you have make it's super nice, super powerful, but then many things break. Like if Dan says you want a tool, yeah, you can do a tool, but you cannot do a tool, or it would be hard to do a tool. For example, if variables are written in a makefile, because then how do you parse that? So I think that so restrictions, depending how you see them, can be powerful in the sense that if you know certain things are not allowed, then you can, if you know that, for example, a package cannot do anything outside the domain of that package, then certain optimizations you can do, especially with regards to say our CI, which currently rebuilds a lot of things, a lot of time. But it has to, because with the current system, it's so free, so you can do so many things that you can never know if you're building one application and then you're building the next application that uses the same modules for the same board, but anything could happen. Like things could be built completely different because it's so free.
I also wanted to ask about like the way we describe hardware now. Like we currently have the approach of these separate conf files. We might somehow replace them or override them from the application. But I wanted to ask, like, what's your opinion, like, in the way we're describing hardware now? For instance, I remember we had a project there at Inter Chile, and we had to use our own board, and we tried to get like an external board and trying just to fetch Riot from somewhere, but in the end we had to fork Riot, we had to hardcode some stuff directly like in the board folder, and yeah, sometimes, especially like if you're working with a development board and then you want to go to an external board, I think it would be really nice if there's a way to describe what I would need, what kind of devices are there, how to handle conflicts when like provided these configurations. I don't know. Are we okay with the way we?
Yeah, well, just that. Yeah, I know currently, yeah, it's not possible because of how the build system is, or the limitations of the build system, and I think that is not that hard. I mean, it's ongoing work from Gaten, who unfortunately he's not here, and but his aim is to do that, to be able to define CPUs and boards outside the Riot tree, but it's very tied it's tied to the current build system, how it solves the dependency, how it includes makefiles, how all of the dependencies are parsed, and but it will be possible without changing the way we do Riot up to today. So, I mean, it's not that it won't be a stopper in the near future.
Does anybody else think it would be a good idea to unify all the different concepts into a single component? You have boards, you have CPUs, you have packages, you have modules. So if we go towards a solution, maybe we don't do it at the first try, right? Because it's big work, but to gradually tend to unify, get a solution that unifies all these concepts into just a component. Make everything a component. At least we have the same problem, but we have it only once. Oh, and also, what do people? Somebody else like? I like a command line interface, but I don't know. anybody else?
Just we put like some random questions just to might or might not be accurate, but just to know what the impression is like. There have been some ideas that has been like suggested offline, some of them, and more than ideas, like questions, some of them by a devil list. And these are some questions that I don't know, like what are your thoughts about some of this stuff?
Like for some things, I think we are kind of hitting a bit of the limitations of what can reasonably be done. I mean, reasonably, because of course everything can be done with systems like the one that we have, but reasonably, that's another thing. And one thing, for example, that is kind of weird that we cannot do is to like download clone packages once. It's crazy that we cannot do that.
Yeah, I once came to the same conclusion that we cannot reasonably extend like our current Mac-based build system and add a branch somewhere and a tool which is basically doing most of what's described there. And you can already do it via what it cannot do yet is like pits to get sources we are different from the sales, but that should be easy to enter. So if you would be willing to give some homegrown solution a try and something is almost working.
But can you, for instance, point to a device driver that has a different version that is living in another GitHub repository? Can you do this kind of tricks? Like,
well, as I said, there's not yet the responsibility to fetch sources from any of the
Another thing, I know that a lot of people like for Sapphire override because they're using the Linux build system, the kconfig style. I mean, I have no clue about kconfig, and from what I gather, it's also not the most comfortable or convenient tool to work with. But I mean, on the other hand, we are claiming to be something like the Linux for the IoT, and a lot of people know kconfig and can be used for.
Use that fire.
Sure, if you like, but I mean, I think it could be also an alternative because I mean we also not want to reinvent the wheel for this type of stuff. I mean, we just want to use and for instance the problem of like having a config or a GUI would be also automatically solved because there are already the tools around for it. So maybe that should be also worth consideration.
Yeah, I know kconfig a little bit, and what's also nice about it exposes configuration to the user very easily. Like you make, I mean, the Linux can make menu config, and you get this nice end cursors GUI. And well, the thing is, like you select the, okay, for Linux you only select the architecture, but in the right sense you would select the board, and then it automatically sets the CPU, and you see what you could define it that way, that you'll see, okay, I have PIRF I2C or SPI, and then I click this, and maybe what I said in the beginning, then I configure the pins of this driver device, what I want to like, and then, I don't know, I think it spits out a common configuration file that sits and I think kconfig does this, that you have like a .kconfig file per module, or per driver in the Linux tree, and this would be a module in Riot, I think. The other thing, what you said, like if we want to, if it makes sense to treat everything the same somehow, like CPUs. I don't know, because I think a board is a completely different concept than a module. It's just a configuration, actually.
Yeah.
Well,
components.
Well, I mean, for packages, I think we already got rid of use packet, right? You don't.
No, not yet.
Not everywhere? I thought there's mostly a module that's kind of the same
No,
name, and then it's a requirement. No?
There's still an open PR to that.
It's because it's used indistinctively, and there is no strict. We don't force anyone to use module or use package.
I think there's a really old issue by me that there is no real semantics to use package. Some packages use it as use your module plus download something. Some packages use it just download the package and then use the modules that are in the package. And so And for that you use module. So yeah, I think having some kind of unification there, and I think the Atom is doing some work into that direction, would be good.
Yeah, I wanted to add something about kconfig. I mean, I'm not an expert of kconfig at all. I did make menu config once or twice in my life, and I'm not. It's not my preferred tool, let's say. But it's because, but I had an experience with Zephyr, and it was really complicated because, of course, you want to expose configuration, but not all configurations. And when you have too much choice, I started to tick things, or yes, no, and at the end my application didn't build because I didn't select a dependency, and I was supposed to know. So it was complicated, and what is nice now in Riot is that you do make, and it works. And I think we shouldn't go that far from that.
Yeah, that was also a worry I had when people were talking about kconfig, because other people were asking for having easier multi-board support. So if you always have to open make menu config to just change the board you want to use, then I think things can get pretty complicated, especially if changing the board then changes some parameters and then something else changes.
I've been using lots in WRT, and as far as I know, they're also using kconfig. In this telecom project, we had like a handful of different target configurations and build configurations, and it was actually super inconvenient to work with because the tooling is not really made to manage different configurations. We ended up like coding a lot of getting kconfig snippets and mixing them together. So while yeah, if you go from scratch configuration, you can easily configure your stuff, but if you have like different stages, for example, you have like a base telecom configuration, and then you want one DSL and one LTE version of that, you cannot easily do that with kconfig. Well, and this is something we do a lot in Riot.
Well, would you agree that having like inheritance of configuration could be like a good approach for us?
Yes, definitely.
Well, I also know, like I have absolutely no experience with kconfig than just following a tutorial like years ago. But at least whatever the tool we use, I think it's really nice the fact of using standard tools. Even though they might not be that good, of course, if it doesn't solve the problem, I think it's we should find something. But I think it's valuable to use something standard because there are other people also developing tools for those standard things. So I don't know if someone has experience with other configuration systems, if they're here in the community, there are other standards that might be used, or even if we can use like different approaches. For instance, we could configure, I don't know, the device description one way, but maybe we can have other kind of configurations in another way. Any comments?
No, somebody mentioned something related with what you said. Like you said, okay, well, but boards are a different thing. And one thing that is different, for example, with CPU, right, is that all the CPUs, so all the CPU packages are named the same. It's a CPU, right? So you got like things that you see, well, it's repeated, right? You have repeated functions. You have things are the same in a lot of packages because they are the support for different CPUs. But one thing I take from some package managers out there, Linux package manager, is that they have a concept of like a virtual package, would be like a virtual interface, and several other packages which satisfy that requirement. So in our case, of course, every application needs a CPU package, but there are several providers for that package. And the same can be said for many of the things alternative that we have. It can be said from a CPU or any other thing where you have what would be an interface, right? An abstract interface which is fulfilled by a concrete package. So that's what I mean when I say you make it the same, but you handle it like externally. So that the amount of different cases that you have to consider when making a build system is limited.
When we're talking about like virtual packages we were talking about before, but there's something in Riot that's called the sudo module, which is basically the same thing. So yeah, maybe if I don't know. I'm not that deep enough into CPU development to know how much hassle it would be. That CPU would basically become a pseudo module, and then the CPU would pull in the dependencies. But yeah, it could be a possibility because we already have something like that.
Well, actually, I mean, the CPU should just be a dependency of the board, and the board knows exactly the CPU type. So if you just call like a CPU, for example, I don't know, Codex something, and the board cancel that, we don't need to have like this this CPU called module.
Yeah. But maybe a port pseudo model or something like that.
Yeah, what actually means, I think, what the package, the virtual package would represent more like the version of the interface. So if one day we change what we say, okay, well now the CPU should provide this additional function, then we know that we can detect incompatibility.
Okay, we are a little bit behind the schedule, but somehow it's really nice to have like some feedback from this discussion. It seems somehow maybe like what we mentioned a lot would be the fact to start checking how do we pass this kind of stuff directly to the code, as Hauke has said before, because whatever we do, if we use the kconfig, if we use whatever, we'll need to tackle that problem first, and maybe it could be a good approach to solve that, and then whatever we add on top, it will be just like an extension to the base problem, which is how do we actually configure stuff. Do we agree on try to start on that small step?
I would say so.
Yes?
I think that the biggest problem is that I was trying to find, or maybe I'm not super good in this, but a way to extract from all the .h files what parameters can be configured, but it's I see no solution than going one by one, and it will be a real pain. I mean, it needs to be done, but it's hard, I think.
The thing is, if we done this, for instance, what Martin said before, if we have to configure other package, we can always have a layer in the middle, but at least in the way how we configure Riot kernel and Riot, maybe we can all agree, like in open discussions in that, we try to tackle that problem.
Maybe a possible approach there would be to find that, because right now it's like buried within H files, which thing can be configured and which not. But maybe what we could do is, instead of looking at the packages themselves, look at the places where the packages is used, and at some point somebody will set this configuration. Maybe.
Yeah, I mean, I think that the non-intrusive approach should be done. I mean, because it doesn't hurt. You would just create new H files. They will live in the repo, maybe taking some space, but at the end they can be leveraged afterwards.
Maybe thinking like we can have a first approach where we have everything working simultaneously, and we like convert a couple of packages to a newer system, see how it works, and play with that. And then like if we like it, little by little, we can convert all the rest of the code. But I agree that we should have whatever we do, we should support the two systems simultaneously. Because maybe the best approach is to have something that is maybe doesn't have all the features, but because we have the old system still in place, like complex, really troublesome packages, we can still do it the old way for temporarily at least.
Okay, let's take a picture of this. Let's open an issue. Let's put this in the task force, and we start with this first approach, and we see how it goes. We can take it. Okay, so thank you so much for this interesting discussion. Thank you.
All right. Hello again, everyone. Yeah, this is welcome to the first Riot Maintainer Assembly. I hope we're making the tradition.
the point of this is we had like a lot of nice presentations and breakout sessions on how to improve Riot on the technical level and everything is the technical future of Riot. I think we also need a little bit of meta talk. How do we improve the community? Or maybe it's perfect, maybe not. What options there? So maybe there's need to talk about things. And I mean, we had like a little bit of this morning with a maintainer tutorial, which I hope, I don't know, I think it was nice, but yeah. We don't have much time. One thing that I found a little bit difficult in these last months is that we often have like discussions, mostly via email or like pull requests, and we think about this. We have this thing called rough consensus. I think it's a little bit based on how the IETF does it, but there's usually some kind of person or role, like the chair, that can actually call the consensus. It keeps track of all the arguments presented, and at some point, I don't know, makes it converge somehow. This is something in Riot we don't have, and I think that's also the reason why some of the discussions go a little bit sideways. So I want to use this opportunity to get ideas and how to improve the situation. Another aspect is that I think consensus is nice to make sure it scales, because rough consensus is a different thing in a group of 5 and a group of 50, and let's hope that the number of maintainers will actually approach that number soon. So, first question would be: do you think everything's like, can we like just continue like this? Is the rough consensus we have right now? Is it all right, or is it only me who has difficulties without discussing?
I mean, regarding the question if this works or not, I think IETF is a good example where it works, and it also scales because then IETF focuses on 5 people, much larger than the Riot together group, which you might communicate forward. So I would say
yes,
it's
I think
a good example. For, I mean, the case of the documents works.
Well,
on a large scale.
I would say yes and no, because I mean it depends on the work group. I mean there are work groups that just get stuck in discussions forever for whatever reason. So I think I mean, and I've got to say, I mean we don't have this person chairing the group or whatever, or like the
chair is only moderating.
Yeah, but I mean only moderating. It's an important role in such a consensus finding process.
So, I mean, bottom line is that, yes, IETF is a good example, but we don't have the same, processes as the IETF. And so, questions like, are the processes we have now, of like, logic consensus, do they work? And if they don't work, yeah, we can look at the IETF, like, what do they do differently? They don't scale to 2,000 people or 10,000. They segregate into like different working groups. There's some kind of hierarchy of processes and stuff like that. So how where should we look to improve our
One question, I mean, that's an outsider. So IETF, normally you have the discussion, then you say the consensus, there's some humming or something like that, or as you said, the chair's point to it. How is it with Riot at the moment? Like you discuss, I mean, how do you end?
People hum at home.
I mean,
it's actually not true. We had long discussions on difficult subjects, like for instance the licensing discussion. But I guess there was for the relevant things was always the consensus on.
I mean, in IETF, you have a humming. I mean, for those of you who not attended IETF before, you have a discussion on site during the IETF meeting, the humming. But this is not a final decision. It's always go to the list, and then you have again a rough consensus. You do not count the number of list members and then the number of people who reply. Just a rough consensus.
But and I really think like I'm not against rough consensus, but I think the IETF model is really good because they do have this role of a moderator that actually does moderate, and that we don't have. And I think my hope was actually that we maybe converge on something where we get this moderation role somehow in our discussions.
But do you envision like one moderator for whole Riot? Or, I mean,
it's more like a mediator.
Do we have good examples where the discussion stuck because of the lack of a moderator?
Yeah, because that's what I wanted to say too. That sometimes the discussion just ended because nobody contributed anymore.
Yeah.
It's not that we have. I mean, the fierce the discussion with like licensing also. There were lots of momentum, and then we came to an agreement. And
so it's similar to an adoption for an IETF, where you ask for adoption, the one is defining.
Or
yeah.
There are also discussions where they all also just ended because apparently no one was interested in them anymore, and then there was this started discussion and without any resolution to it.
And
we have this moderator. Those are maintainers.
So can we take a step back because we're already kind of going to solutions based. What is the problem?
The problem, yeah, that's why I was asking. I mean, can you give a
yeah, that's why I was asking in the beginning. To me, it seems like that many of our discussions they get broader and broader, and more arguments are getting piled up. No one keeps track, and at some point they get stuck without resolution.
Most or some?
Some.
Can you give concrete examples?
Yes, one is would for example be this staging discussion. The discussion about the staging tree, where like to me it seemed like arguments were piling up, but there's no moderator, so I could not like gather the arguments because I'm obviously biased if I have like argument for one in one way, and yeah, I think if there would have been a moderator, maybe it goes a little bit different.
We had this with the moderator also, with, for instance, with the CI system. I mean, we had a concrete problem. It was technically challenging in a sense, and also a little bit like, I mean, it needed a decision making which was not on pure technical grounds. And then we created some group and some moderator. We could also do this with a staging discussion. I mean, that's an ad hoc thing. We should also relate to the subject because I mean, it doesn't make sense to select a group or a moderator that is obviously not interested in the subject. So,
I agree that this approach worked well for the CI system somehow, but it's not a process that is naturally or automatically established. So I mean we have this problem also think on a smaller scale often in pull requests that like there's some discussion and always creating a new kind of I don't know task force or moderator team. I mean for the CI it was not a single person, it was like several people were involved. I think that doesn't scale, that doesn't work well for a lot of discussions. So I think we need some process to find such a moderator or moderator team.
Yeah, exactly. Also, there's like this one pull request we're having now. There's a discussion about how to design the API and how to change it, and it just stalls because we don't have a procedure to escalate. Arguments are presented.
I mean, what does it mean escalate? I mean, there are guidelines how to handle pull requests, even with a deadline and so on. So it's not completely true that there's no process.
I know the procedure. It is just not really clear. In that case, I'm in the position that I don't want to change things. So if I just don't reply anymore, the thing gets stalled, and at some point the contributor will just go away. If I would be on the other side, and if I would need to ping, and if I wouldn't know how to escalate this, I would maybe ask the maintainers. But
yeah, exactly. Yeah, I think this is also part of the guidelines.
And also,
and it's interesting.
The team from the maintainers or from others, if there is interest and the need. I mean, we have done this. So
yeah, maybe we can just like formalize this process that you have kind of a template that you can send to the maintainer mailing list whenever you are in a position, whether you are a maintainer or just a normal contributor. Say, hey, I get the impression that my proposal got stuck. Write a somehow formalized or just email to maintainer and say, hey, I need a moderator for this particular discussion. And then someone who's not directly involved in the discussion, I mean, at least not with a strong position for either side, and is willing to moderate there, steps in. But then we need some willingness in the maintainer community to do so.
So Casper is talking about like some examples. Do you guys have other examples that kind of does it resonate with you as contributor or communicate?
I think there are a lot of, or I've seen, I don't know, discussions in the documentation, how do we handle some files. Usually this documentation are really hard to keep them going on because at some point there's no consensus, and then we try to, I don't know, like ask for some more staff or thinking like other maintenance. It's really hard, and I also feel like if there's no protocol there, what else you can do is like you can write, hey, how do we go? But I also think we need a way at least to have a solution. Like if we are not doing anything, at least make it explicit. Otherwise, we end up with 363 PRs open and a lot of open discussions. But at least I think, yeah, it has also been a problem for me in some PRs. I have, and I'm pretty sure for some other people as well.
Can it be as simple as if some discussion gets opened, if there's no traffic, if there's nothing that has changed within X amount of time, then we say, you know, what's the conclusion here, and either kill it because you know there's no point in just conclude somehow after a certain amount of time.
I mean that's probably the thing. Just formalize this.
Yeah.
I mean,
we ask for a conclusion. If like in n days nothing happens, we say, hey, we need a moderator. We forward it to the mailing list. Somebody on the mailing list says he steps in, and then. But then that's a question: how do we deal with actual technical problems, like decisions that have to be made?
I mean, the question is there? I'm not sure. Is on a discussion level, do we want to distinguish between like discussion and a PR, which sometimes have the same problem, but they are kind of. I mean, we have lots of PRs. It's more like a day-to-day basis, and then we have like this discussion on API changes or introduction of the staging directory, which seem to me a bit on a different level. So they might, and they are more seldom. They are seldom, so we don't have them that often. So we could spend a little bit more effort, like somebody is collecting or piling up, collecting a list of arguments, as we did for the CI, and with a collection of arguments or a testing setup or what is the features we want to try against this, and then we have this solution, and then some hopefully not so biased people give points and judge, and then we maybe with a deadline attached. But I mean on every PR have a big discussion. I think we need, the question is, do we need two procedures, maybe two different sets?
These procedures are only interesting for those questions that are not purely technical, because the pure technical questions are actually not a problem. There are sharp, clear arguments, then they can just be exchanged, and then that's relatively easy. But those things that were pointed at, and that includes the CI, that includes staging, are not mainly technical problems, but are like strategic or community decisions that have like personal feelings, that have political directions, that have also, I mean, some people like this, some people like that, and that's actually the things where we might maybe need a moderator that is more or less sort of sorting stuff out, but I mean, the pure technical stuff that's not an issue.
I think even the pure technical stuff that causes issues. Like we are often having to think this thing that we have to decide between different trade-offs. People come and say, well, this is like this API is clean and it's unclean. We need to fix it, and then another one says, well, but that will increase code size. And then we have like two different trade-offs to make.
Sure, but it's easy to resolve.
No. I mean, it's also the trade-off of binary size or runtime, whatever. I mean,
another example is the priority inversion discussion, where we were talking about enabling by default or not. And the trade-off was ease of use versus increases size of ROM usage. And basically, that was a big discussion without resolution.
That was a big discussion, but a short discussion.
No, I think it's still not resolved.
Yeah, it's still there.
We just
But-
have our consensus there.
Yeah.
I thought there was.
I would say no. So basically, I would say my feel for the hum on GitHub is that it's pretty even. I think. I mean, I don't think there's any clear consensus reflected.
I'm not sure. Yeah, the separating, what's more technical and what's less technical is very, going to help us. Now, I mean, the one thing that all these things have in common is our decision-making process, and there's apparently some, systematic blocks that happen, that appear, where we're not making a decision, and it's just like frustrating for a lot of people, and yeah, are harming because they even just making whatever decision would probably help us a great deal compared to not making a decision. Yeah, and so there's maybe there is like some process or some systematic way of making a decision that we don't have yet that we should elaborate.
Very interesting discussion. I would advise against having the moderators as a point to delegate the decision making. Like that, just to be, don't delegate on the moderators. They shouldn't be the ones making the final decision. They are more like there to lead people into making a decision. Just be careful with that.
I definitely agree. I mean, this was the word of an architecture, the working group chair. It's moderating, not deciding.
Yeah.
It's very careful with
That's actually very important because that contradicts the grassroots philosophy of Riot that we delegate decisions to someone.
Yeah, but maybe it helps if someone feels in charge to track this, like the discussion. It says, okay, come on, let's like this. Yeah, moderate. Yeah, exactly. Yeah, but
like a secretary or something like that.
Then a decision needs to be made, and let's say that it's 50-50, and there's arguments on both sides, such as the peripheral, like, oh, do we try to simplify it in the header, or do we unite it? And this is, goes all the way back to efficiency versus, it's a trade-off. It's just a trade-off, and how do you decide on what's what within a range of?
Yeah, and they're making these decisions all the time. That is not another.
So then why is that decision not being made?
Which one?
The wrong, what is it? Like for the URL, it's like you can either have a whole bunch of configurations in the header, and then it's up to the user to go put that in, or you can do the mapping of all these configurations in C file, and it takes a little bit more space, but then you only expose the easy stuff to the necessary stuff to the user who's setting up those configurations.
it's very technical.
But it's one of these things that
Yeah, but it's
a lot, and it's died. It's still like,
if it's more how about we resolve this. So if there's nobody like keeping the discussion alive, or so it's got stuck because nobody answered anymore. So if we would have some person like a moderator who says, "Come on, let's," and we make a list of arguments in the next. Well, you have time until, but 2 weeks, and then we make a list of arguments.
Well, but sometimes we do this actually, like when someone stumbles upon an issue that is discussed where the discussion seems to be stalled, and then someone writes ping, anybody there?
Yeah.
And so we basically do this, and some of us maybe also feel like responsible for that they sometimes look into that and say, hey, what is up with this issue? Why is there nothing happening here anymore? But yeah, maybe, so I don't know if formalizing this to the sense would make that much of a difference, because then you basically just have one person or a group of people that feel responsible for that, but that's basically not much different from what we have now. Just that there's a dedicated group for it.
Does it make sense on some difficult issues that it gets to the point of a vote? Not so much in the sense that we have to have a certain number of people that say yes, but is there some large number of people that say no, I don't want to do this?
Yeah, it's just what rough consensus means.
But one single person that can block it, but if you have a significant number of people that says no, we don't want this, then it is no matter what the majority is, then it is sort of blocked.
But at some point in the discussion, would the moderator say, okay, now let's just see what everybody says, and this is what we'll decide at this point. Maybe we'll go on, or maybe we need to discuss more, or...
Yeah, but for instance, I also agree somehow with Martin with the fact that we lose track of discussion, and sometimes after a ping, 2 days later, the feature is merged, but the discussion was trapped for, I don't know, months. I also like, I don't know, what do you think about, for instance, we know which PR has discussion, for instance, labeling this discussion, at least you know they're open discussions. Then if we have to use moderator, at least we know what to track, but I found like discussion for 2 months ago that then we start again. I think it's very different if the community knows there are discussions there, at least we can say, okay, this PR, maybe we can go check what's going on. Like,
I have to laugh about this a little bit because this morning in the maintainers tutorial we talked a lot about how to streamline the review process a little bit more, and there was also the conclusion that we maybe need to have some extra labels for that. So it seems to be lately labels seem to be the answer to everything.
I think the advantage of formalizing this stuff is just to handle this process a bit stricter than we actually do, because I mean there are some people who just like for weeks don't go through their issues on GitHub, and then discussions just get stuck, and like you don't know, sometimes you just don't know, like, okay, the other person just doesn't have time, or just so disapproval of the proposed feature that.
But changes the formalized process to pinging the discussion. That changes that, or because?
Well, I mean, I think first of all, like writing to the maintainer mailing list is a different thing than writing ping in the GitHub discussion.
Yes.
And second, then it's also like, okay, someone is responsible in doing this ping. It's namely the person who wants to get the feature in or the proposal to get accepted. So there's a clear definition of who's responsible in triggering this thing. And then we can also say, okay, if it doesn't happen, you can just close the pull request and and just do it, and not like, I leave it open because maybe the person comes back at some point in time. And
It is something like everything is in Bitcoin, and everything is based on tags. Why not just have, I don't even said that actually before, I couldn't listen to it. But why not just having a tag consensus call or something
that was Jose's proposal.
And then you could say something like some rough rule, like the maintainers have to put this, and then after that you have 2 weeks, and then we can put the session. Something, I don't know, some process like that. And then you can have if you are not co-located, then you can have a quick call where you can see another one. Be careful with the bureaucracy and the meetings and all that can get really nasty.
Rust has a similar process to that. They basically separate out the teasing out arguments phase and the consensus building phase, and everyone has a big chat about the pros and cons, and then it goes into a consensus building phase for a week, and in that the rule is no new arguments unless someone comes up with like a whopper, and basically then that's the process, and then they also have fallback on like a committee and stuff. And like another thing that people have is sometimes is voting fallback, like Node.js has that, and people never use the vote because they know that no one wants to just have a straight vote, but because it's there, people they can. There's a way, you'll always have consensus in one way or another, and I think those mechanisms are nice, and it's also about efficiency. If we can make decisions more quickly, we can advance more quickly, and I think that's something that would be really, really beneficial.
Deciding quickly might be value, might be not. It really depends. Sometimes the discussion needs time, sometimes it doesn't need because it's business argument. So the statement alone doesn't mean much.
Yeah, but I mean that could be exactly the responsibility of the moderator to decide whether it makes sense to keep the discussion ongoing for some time, or just say, okay, we can do this, we can try this right now, and if we figure out that it's not working, we can rewrite it easily. I mean, for some decisions, like changing the license and say try it for half a year and then maybe we revert the license is stupid. But for but for the staging directly, just give it a try and see what it actually changes in the daily process. See if it's a good idea or not. It can be worth a try and don't need a long discussion from our perspective.
Last one.
Yeah, we're out of time, huh?
Yeah, we have to.
So, I mean, we cannot do any decision anyway here.
Exactly.
There's 42 maintainers of the maintainers mailing list. Looking around here, basically less than half of the people on site. I mean, yeah, how would you summarize this?
Yes, I would summarize. Actually, I got what I wanted, and I'm a little bit impressed because I really thought that the decision making is actually pretty flawed and very cumbersome and slow and doesn't converge as it should. But not a lot of us think like that. That's I think is already pretty impressive. I think we need like concrete ideas and discuss it on the mailing list.
But I don't know, but I think that we are not quite the right people to decide on those processes, and we should probably ask someone from another science if they have another process for us to.
I mean, for example, the IFM is a good example. You can, if you have a complete lipid model in mind, you can propose this, and you do that, you can like a consultant and
make a study.
No. I mean, it's not, in particular, the current situation is not so bad. It's that you need the external advisor.
Mediator.
That said, like, we're looking for ideas, and so if people come up with ideas, then they'll be studied.
I mean, yeah, that's just something, but also that's how I hear of this is that it's, I mean, it's not as bad as it sounded at the beginning, and as the consensus model is, I mean, most people also like it.
So, are we looking for like some proposals to distribute the talk process or not?
Well, I mean, one thing that we said at the beginning is a little bit like we have like this rough consensus, but without the moderation stuff from the IETF, and that we can like a little bit more push into actually getting at that point. Once we feel that the discussion might need moderation, we just appoint an ad hoc moderator and do this to call consensus. So in order to like take the possibility of just prove a little.
But as Jeremy said, I mean, it's important to remember it's moderation and not decision.
Yeah.
Also, as a moderator, the main duty is to push the discussion and not decide.
Yeah, you might want to innovate a bit also with ITF. It's a bit slow in this kind of thing. I like the example of the an online way so that you don't have to be physically in the same place, or you don't have to simultaneously be together. You can do it.
Auch so Regeln angehen weiter? Nicht, ne? Man könnte
I would point out that even without any kind of consensus on how to make consensus, you know, it's all free to use whatever process
besetzt, dann kommt das halt in die erste Lane und nach 4 Wochen wird es automatisch in die Last Call rein, dann wo dann nur noch sozusagen der Consensus Finding und da steht es eine Woche drin und wenn es dann immer noch nicht gemerged ist, dann geht es halt in den Close State und ist raus.
So it could be, you know, worth like, because if someone finds a really good way of making decisions, then it will catch on. So that would be a good way to proceed.
Aber Labeling finde ich da, ich weiß nicht, weil wir haben so viele Labels, die müsste man immer sortieren. Und
could we maybe try like now with a call from material or call for consensus label and assigning like the moderator in the same issue or PR, and we start with the open issues we have now that need to somehow call for consensus?
I guess so.
We could do a humming.
You could try
I like this labeling. I think it's good to start.
Let's run it past the mailing list, and if no one complains, we basically have a rough consensus to try, and then we can and then we can pick a random pull request that's been open for a while and we just add the tag.
MicroPython.
Then why isn't this merged?
That's one thing that Oleg proposed the other day. We do a lot of this deciding actually, and I think we should. He said we should like maybe just record how we came to a certain decision and log it somewhere.
Yeah.
So use that as a reference and point to it, so we don't have to have the same things all again. I think that's a complete thing we should just do.
Okay, so this concludes the
We
session.
recorded this.
We will have next year also a summit, most likely in Helsinki, somehow around the same time frame, so mid-end of September, we will figure out details and we'll fill out. So, yeah, thanks for coming.
Hey, thanks for moderating.
Has someone been designated to collect slides from the
Oh
presentation?
yeah. We have all the slides and we have also the presentations recorded. We put them online and send a link.
And thanks to everyone involved in the organization of this.
Yeah.
Yes.
Yeah, thank you.
Thank you.